Okay, we're going to do a section that's very similar to the last section. I make this disclaimer. This approach is a little faster, but it's doing the same thing we did in the last section with complex fractions, complex rational expressions, and I don't think we need it because it's kind of the same thing. So if you totally understood what we were doing in the last one, in the classroom, I don't usually teach this, but if you feel really confident in your math skills, you might find this to be a little better. So I'll show you how we do it. Okay, so in the last video, what we talked about is we're going to work this as three problems. We're going to combine the top, combine the bottom, as if it's the only problem in the world, and then we're going to keep, change, flip. Well, what we're going to do here, let's see how they showed it here. We're going to find the least common denominator for the top and the bottom. Now, there's a couple ways to do it, but they're finding this just happens to be a match. I think that's how they'll do all of them. So do you see that if we were trying to just combine the top, our LCD would be 6? And the same for the bottom. Okay, now what we're going to do is we're going to multiply the top and the bottom by that LCD. So we're going to just now distribute that LCD through. So basically, this is a trick for clearing fractions. Do you remember we've seen this before? We can multiply the 6 times everything there, and what happens is all the fractions are gone. So it's a little faster, and maybe you like it. I think it's a little more mathematically confusing, so again, I don't teach it usually in the room, but let's try another one here. So you see my LCD would be 10. Oops, my pen is not working. So I'm going to multiply that top by 10, and I'm going to multiply the bottom by 10. That's supposed to be a 5. Okay, let's send that 10 through. He's going here. Do you see 10 times 1/2 would get us 5? And in the same way, 10 times 1/5, if you need some help with that, check back on some old stuff, but 10 times 1/5 would be 2. Now, we send the 10 through here. We get 10 times 1/10 would be 1. 10 times 1, or I'm sorry, 10 times 1/10 is 1. 10 times 1/5 again is 2. Now here's what's better. It was fast. If you understood that, it was real quick, and now all we got to do is 7/3. All right, try one on your own if you want to give it a shot. Now, the book was using the same one on the top and the bottom all the time. It doesn't really matter. I'm going to use 8 on the top, and on the bottom, my LCD, so I've got 2 and 16, so they could both become 16. Okay, now we're going to send this 8 through to both these guys. Do you see that would be 2 and 3. Now we're going to do it here. We get 8. Then we go here, we get a 5. 16s would cancel, you'd be left with a 5. Okay, so again, now you get 5/3. Now, it's no different than what we were doing, just a little faster. Now, what would we do if we were trying to do this with complex rational expressions? We got I don't knows in here. Well, we're going to play the exact same game. The LCD on the top here would be xy, and on the bottom it would be xy as well. So we're going to multiply the top and the bottom by x times y. Now, we're going to send it through to both of these guys, and then this to these guys. So they've showed it here. It's getting distributed through. The x's would cancel. You'd get a y here. The y's would cancel. You'd get an x there. Now, the beauty of this is you have eliminated the denominator, so you just have y plus x. We do it on the bottom, we'd have x squared minus y. So it makes it faster. Now, we can factor this on the bottom, so we'd cancel that out. Now make sure you can't just leave nothing on the top, you got to make it a 1. So there's our answer. Okay, try it, or you can watch me do it. I'm going to multiply this by an LCD of AB. Okay, I'm going to multiply this through. So A times B, so I'll show this one here. I don't want to show all of them, but especially because this may not be many people's way of choice here, but you see that if we multiplied AB times 1 over A, we'd get B. And if we multiplied AB times 1 over B, we'd get A. Okay, now we're sending this through. Now this one's a little different. You see AB times A over B, the B's would cancel. I'd get A squared. And then here I'd get B squared. Okay, now A squared plus B squared has square roots on the front and the back, but it doesn't have the minus in the middle, so you can't go any further. You're done. And that would be our answer. All right, let's try another one here. Our LCD on the top would be x squared y squared, and on the bottom it would be xy. Now again, I think the book always does it so that they're the same one, but it doesn't matter. Just find the one from the top, find the one from the bottom. Okay, now we're distributing this through. He's coming here. Do you see the x squares would cancel, and I'd have y squared? Goes there, the y squareds would cancel. Get x squared. Same thing here, he's going through. I'm going to get y plus x. Okay, now this on the top is a perfect square binomial, so that I can factor that. Okay, and y minus x is my answer. All right. Yeah, they're going to do this where they have the matching one on the top and the bottom. I don't really know what that benefits you. I don't think it benefits you anything, really. I think it just makes it a little more confusing. So on the top here, we're going to multiply this by x plus 6. Okay, that was the LCD for the top. On the bottom, now this is x minus 6, x plus 6. Do you agree with that? So my LCD on the bottom, this is why I don't teach this. Look how confusing this is going to get. It's going to be x minus 6, x plus 6. Okay, now again, this is faster, but I don't think it's worth it. What I would have done is work these as individual problems and then keep, change, flip, but we'll keep going with this if you're interested. So I'm going to cancel that down. On the top, do you see those would cancel, and I'd have 2 on the top. Now on the bottom, when all of this gets sent to this guy, the x minus 6's would cancel, and I'm going to get 4 times x plus 6. See, these two canceled, and I'm left with 4 times x plus 6. Now he's going there. Now, this cancels with both of those, so they would knock each other out, and I would just have minus 4. Okay, it's a lot faster, but again, confusing. So I'm just going to tidy up the denominator here. I've got 4x plus 24 minus 4. Okay, now there's actually an LCD here, or a GCF on the bottom here. I can pull out a 4. And then those could reduce down to that. Okay, let's try another one here. I'm going to do, again, pause it if you want to do it on your own. I'm going to do this on the top. On the bottom, do you see that this is going to be this? I hope you do. Okay, so we're going to do an LCD of this. All right, on the top, as we cancel, we're just left with a 3. On the bottom, the x minus 2's will cancel. I'm going to be left with 5 times x plus 2. Now he's going to go there, and I'm going to be left with just the minus 3, because x minus 2, those will cancel on the top and the bottom. Okay, now nothing's left but some cleaning up. We've got 5x plus 10 minus 3. 5x plus 7. Okay, more of the same. They're just getting complicated. Let me just see what's left. I always want to see. Okay, I don't know how many more of these because I'm not sure how helpful it's going to be, but let's keep going here. My LCD on the top is going to be x minus 7, x plus 7. On the bottom, it's going to be the same thing. The reason I know that is because that's going to be the same pattern. That's going to be x minus 7, x plus 7. Okay. All right, we're going to distribute on the top here. The x minus, so I'm going here. I'd have 2 x plus 7 left. I'm going here. I'd have minus 1 times x minus 7. That's this is just x minus 7. Now I'm going these guys here. I get 6 times x minus 7 minus 1. So I send it here. The bottoms will cancel and left with just a 1. Okay, now just cleaning up. So I've got 2x plus 14, just cleaning that up. Now I'll send the minus to everybody. So minus x plus 7. I sent that minus to him and to him. Okay, now on the bottom I've got 6x minus 42 minus 1. Now let's clean up the top. I'm just combining like terms. Okay, now you can't cancel individual pieces. All right, the only thing here, well, let's see if this is helpful. The only thing here is that we needed to factor the top. When they do that, it's going to be a minus 3 and minus 4, I can guarantee it. And it is. So they just factor the top, and now here's our LCD. We're just going to play the same game again. Send that through, we get 4 on the top, got some stuff to clean up on the bottom. Okay. Now I'll check it, but I looked at the bottom and I saw, okay, it's going to be x plus 2, x plus 5. That's how they always do it. All right, so we're going to multiply the top and the bottom. We're going to send that through. So that's our LCD for the top and the bottom. It's going to get me just 3 on top. So I'm sending this through here. I'm going to have 4 times x plus 5. I'm going to send this through. It's going to be the x. So I'm sending it here. X plus 2 will be left. So it'd be 1 times x plus 2, but that's just x plus 2. Okay. I'm going to see if there's anything different they got here, or I may be. Yeah, let me see if this is any different. Yeah, not really. I'm going to jump ahead to 1. So the only difference here is that we have this. We've seen this multiple times before. This is going to be like 1 over 1. But as far as contributing to the LCD, it's not going to do anything. So yeah, no, I don't like the way they're doing that. I don't think it's necessary to have a match on the top and the bottom, and that makes it even more confusing. So my LCD on the top is y plus 1. And on the bottom, it's y minus 1. That's all you need. The 1 is not contributing anything to that. So we send it through. They're a match on the top. I'd get y. We send this through here. We're going to get y minus 1. Send it through here. We're just going to get a plus 1. Oh, this was cute. So you get y over y, which is 1. Oh, what did I do wrong? let me check this here. Yeah, no, I don't see. I think that's the same. I don't see why. Yeah, I don't know what happened. The way they did it, it's not going to clear it out. I don't know what they did. Okay, let's take a look at one more here. We're going to multiply the top by x plus 3. And we're going to multiply the bottom by x plus 3. So on the top, these will cancel, and I'm left with just x. On the bottom, he's going here. Give me x plus 3. He's going here, and I'm going to just have that 1. So those will cancel, and I have just the plus 1. So I have x over x plus 4. Okay, these are all repetitive here, and again, I don't think this is the method of choice, so I'm going to leave it at that. Hopefully that makes some sense. It's faster, but I don't think it's worth the heartache.